Hey guys, it's Monday. You're at school working. I'm at home sick working. You can hear from my voice. I should be back on Tuesday. But we always got to be working. So, what did the cats say when the mouse escaped? You got to be kidding me. Today, you're going to be looking through vocabulary with the terms temperature, thermal energy, kinetic energy, and heat. I'm going to encourage you to pause the video and do some drawings to make things a little bit more understandable to you. So let's get it kicked off with kinetic energy. Kinetic energy is the energy an object has due to its motion. So you'll go ahead and pause the video and write this down. All right, welcome back. Go ahead and also circle or underline this word motion. That's really the key to it. Kinetic energy is motion. So faster moving particles have more kinetic energy. You may want to pause the video and take a moment, and you can do a little drawing over here. Like I've got a low kinetic person here who's not really moving, but then below I've got them in high kinetic with their moving, and you can see from the lines. Over here on this top part, you can see I've got a car that's got low kinetic energy. It's moving but not fast. And then I've got three other lines to make it move really fast. So add some pictures to help you out with this kinetic energy. We know that energy is anything that can change matter, and kinetic energy can change matter when it gets put in motion. All right. Now, temperature are everyday terms. You may be used to seeing these, but you're really hot and cold are really not scientific terms, because what's hot to one person is not hot to another, and what's cold to one person is not cold to another. So instead, let's define temperature like this. It's the measure of the average kinetic energy of the particles in a material. So that average word, and you can pause for a moment to go and write this down. So what it is as you have this closed container, or maybe you have a coffee mug, or maybe you have the inside of an oven and you're cooking bread. When you take the temperature of all the molecules and you find the average, that's what your temperature is. And temperature, remember, is just a gauge for the speed of electrons, or the speed of atoms and elements. So in this picture over here on the left, you can see that there is temperature for sure, but when you add heat, since the particles are moving faster, the kinetic energy increases. Therefore, this thermometer gauge gives you an increase in temperature reading. If you want to draw something over to the side with low temperature and high temperature, you're more than welcome to. There we go. So what happens is when the gases increase in temperature, they start moving and bouncing. And as they start moving and bouncing, they start putting more pressure and containers on the walls, which is really, for example, when you have soda and you're shaking up that soda can or that soda bottle, and the gases are trying to escape, they're bouncing everywhere. But it's when you turn that cap or you pop the top of that they really explode out, because they are trying to escape. You put a lot of pressure on them. There are three types of scales. You're more than welcome to add these if you want. This is kind of a little bit of a deeper dive. But this is the Fahrenheit scale that we use mostly in the United States. It doesn't make a whole lot of sense. It's also part of the customary scale, which are inches and miles and feet and yards, pounds and ounces. At 212 degrees, water is boiling. And then down here at 32 degrees, water is freezing. But when you jump over to the Celsius scale, which is also part of the metric system, grams and kilograms and meters, 100 is boiling, and then 0 is freezing. But leave it to the scientists, because, they want to make work even shorter for themselves. So in order to write less numbers, they invented this scale that's called Kelvin. And what's great about Kelvin is that at 0 Kelvin is what's called absolute zero. It's where an object particles are not moving at all. And I know still it freaks some of you out that the particles in this pencil are moving, the particles in this paper are moving. to know that. And as far as I know, there has not been a way to get something down to negative 459 degrees Fahrenheit to absolute zero. But if you find that, please let me know. I love being wrong. Your next box is about thermal energy. And this is their 2.2 paper that we're continuing to work on. And we'll write down here in this thermal energy down here. There we go. And thermal energy refers to the energy that's contained in a system that's responsible for its temperature. So this thermal energy was lower, but when you increased the heat or added heat, the thermal energy rose. And you're going to see that is that, yes, that when you increase heat, you increase the temperature increases. And when you increase heat, the thermal energy increases. And when you increase heat, the kinetic energy increases. In order for you to figure out the amount of thermal energy, it really depends on three things. The first one is temperature, because the faster molecules are moving, the more heat that's being generated because of the movement. Also, the total number of atoms, like with this coffee cup and this bathtub, even though they're both liquids, and even if they're at the same temperature, the bathtub's going to have more thermal energy because it has more total atoms. And it also depends on the state, because liquids and gases are already moving faster. That means they have more thermal energy than solids. So please make sure you go ahead and pause those as you need them. Maybe make some drawings on the left-hand side. Here's one of the drawings that you can add. You've got a cup of tea at 75 degrees and a tub of water at 75 degrees Celsius as well. Which is more thermal energy? Well, it's the tub, yes, because the tub has more atoms, which means you're going to have more. Yes, it would take probably longer to heat, but you're going to have more. You're going to have more atoms, so you have more collisions, and so therefore you'll have more thermal energy. Thermal energy is what you really may have been calling heat, but they really are not the same thing. They are really completely different. Our last piece, our last section here on 2.2D is heat. And our definition of heat is the transfer of thermal energy from one object to the other because of difference in temperature. And thermal energy will always flow from that warmer object to that cooler object. So for example, when you get that hot piece of pizza and it's sitting on your plate, where is the energy going? It's leaving the pizza and going to the air until it cools down. When you take out a cold drink from the refrigerator and you're seeing condensation that's on the outside, why is that happening? It's because the warmer liquid, let me grab this over here. There we go. So you've got the warm air on the outside that's cooling the cool matter on the inside. Warm is always going to cold, which is why you start seeing those sweat beads on the outside, which is condensation. I've got a song for you. So please go ahead and go back to 2.2B and listen to your new favorite song of Hot and Cold. See you later.